In exercise 5.8, we have something a little different than usual. Instead of the usual theoretical question, we have something more practical. So we have a mass of, for part A, of 0.2 kilograms attached to a spring with K equals to 80 newtons per meter. And the other hand is fixed, so the only part that's going to move is where the mass is attached. So let's make a little drawing. And here we have our mass, M. I'm going to do a little better so it's clear to see. Here, mass M. Okay. Now we have to find our angular frequency, and the period. So if you remember correctly, W is equals to square root of K over M, which is square root of 80 over 0.2, which is square root of 400, and which is 20. Okay, 1 second. Second power of negative 1. Then we have frequency, that is angular frequency over 2 pi, which is going to be 20 second power of negative 1 divided by 2 pi, which is going to be about 10 over pi, the second power of negative 1. And then we have period, which is 1 over f, which is then going to be equal to pi, or divided by 10 seconds, or 0.1 pi seconds. These are our three answers to the problem. So of course, at the 3 different points, the 3 different questions. Okay. Now instead, for part B, we have instead something. We have the continuation of our problem. So we have the x naught, the position is 0, and v naught, the velocity is 40, 0, velocity is 40, and the position is 0. So it's asking what are the constants A, so the amplitude, and our angle, phase shift. Well, let's revert the formula that is also given to us. So A cosine of angular frequency times time minus the angle, or phase shift. So we're going to have x at 0, let me write it, is equals to A cosine of, well, angular frequency times 0 is 0, so let's rewrite just to show so you can see it. That's a time 0 first, minus the angle, which is then going to be equals to the angle, so A cosine of negative phase shift, which is equals to 0, because we said that x at 0 is 0. So if we solve this, we have to make sure that our cosine is equals to 0. This means that our angle has to be equals to plus or minus pi over 2, or both ways for us. Now, velocity instead, in terms of t, is going to be equals to the x dot of t. So let's derive x is going to be equals to w a, negative quantity, sine of w t minus the phase shift. And we said that at 0, so x dot at 0 is equals to 40, and it's equals to this thing that we just found. So it's equals to negative w a sine of w t minus phase shift. Okay, so now we know that our angle is actually plus or minus pi over 2, but you have to remember that our t is equals to 0. So instead of t, we write 0, and so this part here will end up being 0. So we're going to have 40 equals to negative WA sine of negative phase shift. Now, sine of the angle will have to be equals to negative 1 to get rid of this negative that we have in front. So we're going to have that negative the angle is going to have to be, what is equal to -1 for sine? It's going to be equal to negative pi over 2. So negative the angle is equal to negative pi over 2. And we said that's equals to -1, so we can rewrite as 40 equals to WA, which then equals to A equals to 40 divided by W. And we said before that W is equals to 20, so it's equals to 40 divided by 20, so 2. And there's our amplitude. There's our final answer, this part over here. And we can rewrite the whole formula as x of t is equals to 2 cosine of the angle of frequency, which was 20, t minus pi over 2. And that's our final answer.